Hello, this is Mr. Wakefield. Welcome back. We're looking at the last section here in the packet, section section 7.6, and we're looking at, in particular, solving equations that have radicals in it. Now, this is not the only time this semester that you'll see equations with radicals in it. But the difference is with these equations in this section, the radicals have variables underneath the radical. And so basically the way you want to think of that is you want to think of it as the variables being stuck underneath that radical, and you need to get them out of that radical, all right, so that you end up with just a normal looking equation. Earlier in this packet, we saw equations with fractions in it, in particular, fractions that had variables in the denominator. Let me just review that with you. And what ended up happening is when we had those equations with fractions in it, what we wanted to do first right away is to get rid of the radicals. And then when we did that, we either ended up with a linear equation like this one, or we ended up with a quadratic equation like this one down here. That same exact thing is going to happen here today, where instead of having fractions that you want to get rid of right away, you're going to have radicals that you want to get rid of right away. And then when you do that, the same result will occur where you'll either have a linear equation or a quadratic equation. You just need to determine which one it is so that you can then pick the right method to finish the problem off. Another area that is similar to the fraction equations, though, is the fact that you remember that we had to check our answers. Okay, you need to do that same thing with radical equations. Again, when I say radical equations, I mean equations that have variables underneath the radical. All right, now the way in which we check is a little bit different, but we do need to check nonetheless. So we'll get to that, but let's get started here and go through the steps. So it says here, rewrite the equation so that the radical term, and in particular the radical, if there's something outside the radical, it would be easier to get rid of that as well. I'll talk about that, even though that's a part of the radical term. So it's the radical itself you want to get alone normally on one side of the equation. All right. And so that, as you can see here in problem A, that's the case already. You have a radical alone on one side. So we go right to the next step, and it says to square both sides of the equation. Now, please, you guys, please, this is so important. Put a bracket around the entire left side of the equal sign and put a bracket around the entire right side as well. Okay. As you'll see here coming up, that is going to be very important. Right now, not as big of a deal, although that still is a big deal. It's still important in order to be accurate and to get it right, but especially going to be important later. But if I do square both sides, then as we hinted at in the last section, 7.5, when you square a square root, you end up getting what? You end up getting what's on the inside. All right, I said that the only exception to that would be if there was a negative number underneath here. But when you've got a variable underneath here, you're not going to need to worry about that. I know there's a minus there, but that doesn't make the whole thing negative. Okay, just trust me when I say that when you in these problems, you don't need to worry about that. When you square a square root, you can just say 5x minus 1. In other words, the square cancels out the square root. All right, and you just get 5x minus 1. On the other side, you get 64, don't you? And as you can see now, the radical is now gone, and you have what turns out to be a linear equation. All right, as I promised you, get rid of the radical, and then you either have linear or a quadratic equation. This time it's linear because you don't have an x squared there. It's just an x. So we do our normal linear method in order to finish this problem off. Okay, but you need to get rid of that radical first, all right, by getting the radical by itself and then squaring both sides, and then that, if there's only one radical in the problem, that should get rid of it, all right. And so there you go, x equal to 13, but as I told you guys, very important, you got to check your answer just like the fraction equations. Okay, so let's check our answer. How do we check our answer? You actually have to go back to the original equation and plug the thing in. Okay, you got to go through the whole process of plugging it in and seeing if it's true or not. Okay, So you can see I plugged it into the original equation. Okay, not this equation down here. It's got to be the original. All right. Then we figure out what each side is equal to separately. That means to keep the two sides separate. Don't try to combine the two sides at all. Okay, don't move things from one side to the other or do the same thing to both sides, like squaring both sides or anything. No, no, no. You have to just keep this the way it is and figure out what each side is equal to, doing order of operations. All right, there's no variables here, so just do order of operations. In order of operations, we always do the inside of a radical before we do the radical itself. Multiplication comes before subtraction on the inside. That gives me 65 minus 1, which is 64. And as you know from earlier in this chapter, a square root radical is equal to the positive square root, which is 8. And so you can see that this is true. Okay. And so because it's true, we can then go back and circle this. If it had been false, we would cross it out. And I'll get into that here more coming up. All right. Continuing on. Problem B. We need to what? We need to get that radical by itself. It's not by itself yet, unlike over here. Oh, but can we square both sides right now? No, you cannot. Okay. Don't write this down. Do not write this down. In fact, I'm going to erase it here in just a minute. But if I were to square both sides right here, that would mean that I would have to, since there's a subtraction in between these two terms here, I would have to multiply this thing out. All right. And it would have 4 different answers. All right. Something like this right here. You would have to do something like this. Again, don't write this down. Okay, this would be a complete mess, though. You'd have to do something like this, and no other way will work, you guys. You cannot just square each part, all right? Remember in Chapter 5, let me remind you, when you got 2 terms inside of a bracket and you square it, okay, you can't just square the 5x and the 4y and that's it. You've got to go through this whole process. All right, it's the same thing here when you got the 2 terms with the minus in between it. And if it had been a plus, it'd be the same thing. You'd have to write this whole thing out. Okay. That can be done, but boy, you don't want to do that. All right. There's a much easier way. Let me show you. We're still going to have to square a bracket with 2 terms in it, but it's going to be a much easier one to do. So what you do, like it says in the first step up at the top of the page, is you need to move things around so that you basically need to get the radical by itself. Okay, let me highlight that. This is what you need to get by itself. All right, the radical, right? So I'm going to pretend for a moment that that radical is a variable. We kind of did that with the absolute value problems earlier, where we had to get the absolute value by itself when we pretended like it was a variable. It's the same idea, you guys. All right, how would I get that variable by itself? What I would do, as you can see there, is I would subtract the 3x over, since this is a linear equation. Subtract the 3x over, get the term that has the variable in it by itself, the one that you want to solve for, not the x, but the one you want to solve for. Get that by itself and then divide out by -1. Let me show you. So we subtract the 3x over. I get -y is equal to -3x minus 5. And then I divide out the -1. We did this back in Chapter 2 when we were doing y equal to mx plus b. Okay, those problems. And then we divided both of these individually by the -1. And whenever you divide by -1, that just changes the sign of what you're dividing into. So that would be y equal to positive 3x, positive 5. Okay. Same exact thing happens here, you guys. In fact, I'll write down the same steps. Okay, so whatever you did in this pretend problem up here with the y, you do the same thing down here. Again, very similar to what we did with the absolute value problems. Okay. You could put the -5 in front of the -3x. I just like to put put it in descending order of degree here with the x to the first and then no x at all. Either way, though. So then I divide out the -1 just like I did up here. You do it exactly the same way. Okay, the -1s cancel here. All right, and we just get the radical by itself. This. And just like we said up there at the top, you get 3x plus 5. Now you what? Now you square both sides, because now the radical is by itself. Do not square both sides until that time. Okay. Now, when you square both sides, as you know, that gets rid of the radical, just like we said in the last problem. But here, what do we get? Here we get 3x plus 5. That bracket's being multiplied together twice. All right, just like I said a few minutes ago, when you got a two-term polynomial being squared, okay, in brackets there, you got to write it like this. It's the same exact thing right here. Okay, bracket squared, you got to write it like this. When there's two terms in there separated by either a plus or a minus. In this case, it's a plus. So we get what? We get, and by the way, we got rid of the radical, didn't we? So we either have a linear or quadratic equation when that happens. We always distribute, at least for now, we'll see other things later, but at least for now, when you have either linear or quadratic, you're going to clear out your parentheses first. And you'll see here that when we do that, it's going to be quadratic, isn't it? Because of that 9x squared right there. So since it is quadratic, you guys, what we do is we move all the terms to, as we learned at the end of chapter 5, we move all the terms to one side. And since it will have an x squared term, 9x squared, it'll have a x term plus 27x. And because it'll also have that term with no x at all, plus 18, that means that we need to try to put it in this. First of all, we need to put it in this order, okay? But also we need to do, after we do the GCF here, we always factor out the GCF first. We need to do the Bary method in order to factor this type of trinomial here, okay? Three-term polynomial. What would that be if we did the Bary method on that? That would be, we know that the numbers positive 2 and positive 1 will work here, wouldn't they? Because they add up to 3 and they multiply together to be equal to 2. And 1 times 2 is the number that you use in the Bary method there. So it's going to be plus 2 and plus 1. You don't need to do the last step of the Bary method right there because those two brackets are already prime. But what we do have here, you guys, is we have three factors there. Again, a reminder from the end of chapter 5, when you have that type of situation, all right, a single term times a bracket, you set all three of those things equal to 0. If the first one doesn't have any variable in it, then that doesn't give you an answer at all, but the other two still can give you an answer. That same exact thing is what we got going on right here. Same exact thing. All right. So we get what here? We get 9 equal to 0, or x plus 2 equal to 0, or x minus 1. X plus 1 equal to 0. No solution here. Okay. This one is x equal to negative 2, and this one's x equal to negative 1. Okay. Don't worry, we're not going to need a lot of room here for the third problem here. That's why I kind of cut over here. But don't circle these yet, though. What do we got to do last, you guys? We have to check our answer, don't we? Okay. Anytime we get an answer in a radical equation. All right, for x equal to negative 2, we plug it into the original. Again, it's got to be the original equation. All right, let me zoom in here. As I do that, plugging it into that, I get 3 times negative 2 minus 3 bracket negative 2 plus 7 equal to negative 5. Okay. What do we get there? We know that one side is negative 5 right there. The other side here, we got to do the inside of a radical before we can do a radical. 3 times negative 2 is negative 6. plus 7 is 1, so we got square root of 1. You got to figure out the radical before you can do multiplication and subtraction over here. The radical is equal to 1. But then when we do the multiplication and subtraction, I get negative 6 minus 1, don't I? But negative 6 minus 1 is equal to negative 7. And so this is false, isn't it? This is false. And so what do we do with a false answer? We go back over here where we go up here. That's where it is. We go up here and we cross that thing out, don't we? Okay, just like we did in the fraction equations. We cross that thing out, and we now need to check the other one. Okay, x equal to negative 1. Let's see if that one's okay. I plug in negative 1. There we go. Sorry, that fell off the screen there. There we go. And what do we got here? We've got 3 times negative 1 is negative 3 plus 7 is 4. We then got to figure out the square root of 4 before we can do the multiplication over here on the left. Square root of 4 is 2. If I then multiply, I get negative 3 right here. Negative 3 minus 2 is negative 5. And this is true. Okay. So when it's true, what do? We circle it. So we circle the good ones, keep the bad ones. And just like with the fraction equations, you guys, all right, the method I'm showing you here will always give you all the good answers. Any good answers that exist, this method will give it to you. It's just that sometimes you get some bad answers thrown at you, so you just need to check the answers to so that you can get rid of the bad ones when you find them. Okay, when you get this false situation, like right here. Okay, so we throw that out because it was false. All right, so please remember to check your answers not only with fractions and equations that we saw at the end of Chapter 6, but also right here with radical equations. What I'd like you to do right now is just do problems 1 and 2. We're actually going to do the rest of the problems on a separate video. Okay, but right now just do problems 1 and 2, and when you're done with that, hit the play button and we'll look at the answers. Okay, looking at the answers here, you see here in number 1, the radical is not by itself. Same thing in number 2. And so what I do again is I pretend like the radical is a variable. This is just a visualization technique, you guys. You don't have to write that down, y minus 5. I just want to make sure that you are certain that you're doing the right steps here. And doing that visualization technique by pretending like it's a variable is a way of being certain about it. Being certain that you're doing the right steps and you're not just guessing and hoping that you're right. We know that when we have y minus 5 equal to 0, we can get y by itself by adding the 5 over to the other side. And so that's exactly what I did in the real problem here. Okay, and I got 3x minus 2 square rooted equal to 5. I then squared both sides right away because the radical is by itself, and I got what? I got 3x minus 2, no radical because the square canceled out the square root, and then I got to 25. Well, that's just a simple linear equation, thankfully, all right, that we've solved many times. I just need to move over the 2 and then divide out the 3 down here, and I get x is equal to 9. X is equal to 9. But, sorry, that's off the screen there. And so there it is, x equal to 9. So then I then check my answer. Inside of the radical comes first, 25. Then you calculate the radical before you subtract. And as it turns out, it is true. 0 and 0 are equal. And so you can go ahead and circle this for that reason. Again, if it had been false, then I would cross this out. And since there's nothing left if I had crossed it out, okay, since there would be nothing left, I would have said no solution. But because it was true, I went ahead and circled it. Okay. Number 2. Again, pretending like that's a variable right there, that radical, I got what? I got y plus 7 is equal to x, right? How would I get y by itself when you have a linear equation, even when you got two variables? The way to do it is to get the term with the y in it by itself by moving the other terms over to the other side, adding or subtracting them over. This is assuming there's no parentheses to distribute out or anything first, and there's not. So I'm just going to subtract this thing over. All right, and the y is now by itself, x minus 7. And so that's why in the real problem here, that's exactly the same thing that I'm going to do. I'm going to subtract the 7 over, and I get the radical by itself equal to x minus 7. All right, I then immediately squared both sides, just like I did in the second problem previously before the one that's right up here. Okay, I square both sides. All right, I've got the two terms over here. The same type of thing is going to happen where because you have two terms inside of that parenthesis right there, you got to multiply this thing out like right here. Okay, you got to do it that way where you write it out twice like that, multiply it out, and this is what you get. All right, you can now clearly see that it's a quadratic equation because of the x squared right there. And so I then need to move all my terms over to one side and put it in this order as well. Make sure the x squared is positive. And I say all of that because in order to do the Bary method in the way that we learned it, you want to make sure that these are all in the correct order, all right, in this order, and you want the x squared to be positive. All right. If the x squared was negative, then we can move all the terms over to the other side and it would become positive. But because it's positive already, it's in the right place. We're good. So now I factor this thing and doing the Bary method. This is what I get right here. I then set those equal to 0 since I'm done factoring. And my two possible answers that I get are 12 and 4. Oh, but I crossed out the 4. What did I do that for? It's because when I checked my answer, which as you now know we need to do, the 12 ended up being okay. Let me zoom out a little bit here. The 12 ended up being okay when I checked my answer. All right. But x equal to 4, when I checked it down here, I got 3 plus 7 equal to 4, which we know obviously is false. All right. And so, therefore, I circled the one that was true, and I crossed out the one that was false. All right. Now, this doesn't mean that you're always going to get one good one and one bad one. All right. Sometimes they're both good. All right. It's just that that's how it worked out here in problem number 2, and also the problem right above it, problem B. Okay. So you cross out the bad and you circle the good. All right. And again, it's so important to remember to check your answers. All right, so again, we're going to complete this worksheet on a separate video here. Some different types of problems at that time, but in the meantime, let me know if you have any questions, and you have a good day. Take care.